if you have hot air balloon, it may look something like this. Okay, my drawing not really that good. So you have to consider a hot air balloon. You have a basket here, so you have a weight. But you need to know that since the hot air balloon is surrounded by atmosphere, the atmosphere is acting as fluid. So they actually displace a portion of air away. Of let's say the atmospheric air. So in case question gives you density of air and also density of the hot air inside, usually we don't really use this. Okay, even though this is the reason why it can float up, because density of hot air is less dense than the density of the cold air. But nevertheless, when we find upthrust, we need to use FB equals to rho Vg. So this rho we should use, let's say here is 12. So density of air, not hot air. Hot air, let's say, is 15. We just use 12. Okay, so 12 times how much volume of this balloon. Okay, how much volume of this balloon, and then times 10. So be careful, do not use the density of the hot air inside, but rather the atmospheric air outside, because atmospheric air outside is the fluid being displaced. And fluid being displaced will give you the buoyant force, which is acting upward like this. Acting upward like this, buoyant force. So this is the application of Archimedes principle for hot air balloon. So if your FB is actually more than the weight, it will rise up. If it's the same, if it is the same, therefore it will remain stationary, not moving up, not moving down. Okay, what if the FB is less than the weight of the basket? So you actually go down. So you can control the amount of air inside the balloon to control the volume. Okay, you can make the balloon bigger, you can make the balloon smaller. Another factor is hot air inside is less dense than the cold air outside. So less dense air will actually help the balloon to go up even more.